which is nice. I gotta be a little careful how I do this. Okay, we descended. Great, so now we're actually down here. And
Alright, hey
walking up ladders,
guys.
even when they're on the side, is not a problem.
Welcome to my worst video
Now, I
ever
will say,
to be filmed
there's another way you can monkey wrench into this whole thing. As you can see,
on
I
channel
use it flipped 90 degrees this way.
Just
I'm
Joe
not
TV
sure. I've seen multiple pictures and multiple perspectives. But if we were to
1256
switch the entire
and
thing by 90 degrees,
Ben Play
the easiest way to
16.
do this being to add a gyro. Good news is we brought the capsule with it. However, given that your player doesn't flip
Here we go,
and
my
you're
part
still
in
in this
Brookhaven.
orientation, I am now probably not going to be able to do this, but I will see. Yeah, it is not built now. I literally can't get through there. So it works in some ways. In some ways it doesn't. Really, if you were to get proper stages, you know, like survival stuff, you want to build it more actively than ISS, which of course was built with the actual way the space works in mind, so it works great in real life. You really need to build it all on one plane, no flipping around, no nothing, so that all the entryways and walkways.
You know what? Let's become a cop.
To standardize
Hi
docking
guys.
spaceships. But I am just really glad that we were able to successfully dock it at all. Well, I was just scrolling through some comments on the last video, and I saw somebody say, Speed, try using the magnets from Crate Propulsion to make the stage separation work to connect physics and techniques. And I was like, what? What magnets? And I'm like, oh wait, there's like a bunch of new versions for Crate Propulsion, which is what we're using for the thrusters. And then we have these magnet blocks, and it's actually quite promising so far. These seem to be working pretty well. Not only will they only work if both are toggled on, but they can even repel each other as well. If I were to flip this around so that both of these are the same space, see, they push each other apart like real magnets would. So I'm going to go to space right now in the new world because it kind of messes up old world, which is a bit of a problem. So may or may not have broken backwards compatibility if we were to use this, but I'm going to go test this out. And it might be that the whole docking thing I just made is completely irrelevant, which, well, it wouldn't surprise me. That was, it's like almost a near perfect docking experience. I can't believe I'm just finding this now. I didn't know it updated, and I certainly didn't know it added magnets that basically allow you to perfectly dock it. You even can just get kind of close to it, and it just is like, oh yes. Okay, I guess we're not now, but like somewhere around here, and it oh yeah. I don't know if it's able to find its way into there. It'll find its way eventually. This might be the best docking system. It's not so extreme that it like freaks everything out and causes everything
construct massive rockets before they lift off from the launch pad. In this video, we see inside the building and how it's been used for more than half a century.
What am I doing? Nice guys. Very easy. I can't find part of that. You didn't see me something.
Return astronauts to the surface of the moon. Construction of the VAB started in 1963 and it took 3 years to build. The building cost $117 million. That's more than $1 billion in today's money. Over the years, they expanded the facility around the building and also added the NASA logo, sometimes called the Utah logo. Is Launch Complex 39A and 39B, more than 5 kilometers away from the VAB. The large distance is mainly for safety. This path is called the Crawlerway. It's a 40-meter wide double pathway road. When the rockets are ready, they are transported from the VAB all the way to one of these 2 launch pads. They use some massive machinery to get this done. We'll talk more about this later in the video. These enormous rockets are built in quite a few different pieces. These rocket pieces have been built in several locations across the United States. Then they are shipped to Kennedy Space Center in Florida. Some of the pieces arrive by barge on the water at this turning basin. And other pieces can be flown by airplane and land on this runway, which is built with the shuttle program. Another way they can arrive is by train. Then the pieces of rocket are brought over to the smaller building next to the allow for larger rockets. However, as of the year 2024, there are no current plans to do this. On the sides of each high bay, they call these towers. So this is Tower A, Tower B, and then C, D, E, and F. They go all the way to the roof. Right down the center is the transfer aisle, which runs the entire length of the building. On each side are retractable doors, large enough to fit the massive parts of the spacecraft and rockets. Despite the size of the doors, they are not the largest openings to the building. Each high bay has 4 door panels that move left and right, and then 7 door panels that move up and down. It takes about 45 minutes to completely open the doors. The main part of the building has no air conditioning, but once these doors are opened, it does the high bay crane went past recovery. Both cranes worked together to lift and rotate the rocket stage. Now it's the high bay crane used to lift it the rest of the way. This all happened very slowly. The first stage weighs about 132 metric tons. The crane operator can't afford to make any mistakes here. They bring it over into the high bay and gently set it down on the mobile launch platform. On the sides of the high bay are retractable multi-story to access different parts of the rocket. Next, the crane lifts up the second stage of the Saturn V. More platforms can now be moved in place. Now the third stage. Right above the third stage is where they put the instrument unit. This is like the brains of the rocket, controlling it all the way through the launch. The very top part includes the command and service module and the lunar module, which is the part that actually lands on the moon. This whole section is lifted up as well and gently placed at the very top of the rocket. During the peak of the Apollo program, 3 of the high bays were used at the same time to assemble the Saturn V rockets. Once a rocket is ready to go, the work platforms are retracted, and the high bay doors are opened. This is called the crawler transporter. This is what moves the rockets all the way to the launch pad. NASA built 2 of these enormous machines. It slowly moves underneath the mobile launch platform
Yeah.
and lifts it up. Now the rocket can begin its journey to the launch pad.
I'm burning into this. Hey, if you want
The crawler
to be friends
transporter
with
only
me,
goes a little over 1 kilometer per hour. This means it will take several hours to get to the launch pad.
here.
All that work, and we're finally ready to launch a mission to the moon.
Thank you.
After the Apollo program, NASA started making plans to support a reusable spaceplane, the Space Shuttle. There were 135 shuttle missions over a period of about 30 years. The shuttle had missions in low Earth orbit. It was also used to construct the International Space Station. To save money, they tried to reuse what they could in the VAB, but there were some specific changes that were needed to accommodate the shuttle. There's quite a bit of height difference between the Saturn V and the Space Shuttle. This means the platforms in the high bays couldn't be used anymore. Some of these platforms were modified and then relocated specifically for the shuttle program. There were 4 pairs of these platforms. High bays 1 and 3 were mainly used to assemble the space shuttle. High bays 2 and 4 were used to process and store the external tank for the shuttle. They were stored in the checkout cells on the sides of the high bays. High bay 2 was also used as a safe haven in case of hurricanes. And high bay 4 was also used to sometimes store an orbiter while it waited for the next mission. The north entrance to the transfer aisle needed to be widened by 12 meters to allow the orbiter to enter. A slot right here allowed for the passage of the vertical stabilizer. The launch umbilical towers were permanently moved over to the launch pads. During the shuttle program, they called it the Fixed Service Structure. The Saturn V mobile launcher was repurposed for the space shuttle and renamed the Mobile Launch Platform. The first part of the shuttle to be assembled is the Solid Rocket Boosters, or SRBs. They are built in several different pieces with their solid fuel already inside of them. One by one, they are lifted up by the crane, moved over to the high bay, and assembled on top of the mobile launch platform. The work platforms are moved into position around the SRBs. Shuttle was retired in 2011, it was time to prepare for the Space Launch System, or SLS. This will be used to
Guys,
launch the Artemis
write in the
mission,
comments
which will
what
return
game I
astronauts to the
should
surface
download.
of the moon. The VAB underwent a massive renovation process that included replacing much of the wires and cables that were installed in the 1960s. The Space Shuttle platforms in High Bay 3 were removed and new work platforms were installed for SLS. There are 10 pairs of these platforms. These are smaller, customizable platforms that can even move up and down as needed. The crawler transporter was upgraded, and new mobile launchers were built. The SLS rocket is much heavier than previous rockets. SLS is launched from Pad 39B. 39A is now used by SpaceX. Stacking the rocket is very similar to what we've already done. NASA is getting quite good at this. SRBs are stacked first. These are very similar to the SRBs on the Space Shuttle, but with a few changes and upgrades. Lowered between the SRBs. And finally, the upper stages. Inside here is the brand new Orion spacecraft. Once we're ready, it's time for the rollout. The first SLS mission was Artemis 4, launched in November of 2022. This was an uncrewed
Thruster propellant low.
The next mission, Artemis 2, will launch 4 astronauts around the moon in 2025. This will be the first time that astronauts have left the moon since the 1970s. Is a testament to what humans can achieve. We can solve problems and do things that were once impossible. In the future, people like this, those that have strong backgrounds in science.
Thruster propellant low.
Not just reading a textbook, but actually trying it out. This is a very effective way to learn. You develop a deep understanding so that you're better prepared to meet the challenges of the future. By doing Brilliant for just a few minutes each day, you'll develop strong problem-solving skills and a powerful habit of learning. Brilliant has thousands of interactive lessons in topics that are relevant to the future, like math, programming, and AI. For me, Brilliant makes things come alive and is a reminder that learning should be fun. You can try it out for free for a full 30 days. Everything Brilliant has to offer. Just go to brilliant.org/channel. You can also get 20% off the premium subscription.
Payload released.
Building a car for the astronauts to drive on. This was very different from driving here on Earth. Just getting to the moon was hard enough, and they could only get so they built a vehicle and they carefully loaded it, and they did it successfully. Let's take a look at the lunar roving vehicle, how it was stored, driving it on the moon, and of course the entire unfolding process. Let's start our story. The idea of driving on the moon wasn't new. Science fiction writers have imagined lunar vehicles as far back as the early 1900s. Engineers came up with their prototypes. In the 1960s, NASA was planning to actually build one of these vehicles. To understand how challenging this was, in the background, NASA entered the moon with the Apollo program. They landed astronauts on the moon for the first time in 1969.
Thruster propellant low. Payload released.
Each mission is launched on this rocket. It's called the Saturn V. Up at the top is the Apollo spacecraft. As you notice, the service module and the lunar module, sometimes called the moon. The Saturn V launches into space in
Payload released. Payload released. Payload released.
Instead, each wheel has a woven steel wire mesh with titanium chevron treads to prevent sinking into the lunar dust. The wheels were prepared to go up as high as 25 centimeters. The stiff frame kept the mesh from deforming too much. Each wheel had its own independent electrical motor. This way, they would still be able to drive. The wheels had feeders to control the lunar dust.
Payload released.
Turning to the left or right involved all four wheels. This was all done with the hand controller. Push to go forward, side to side to steer, and pull back to stop.
Payload released.
The hand controller would send electric signals down to the mechanical parts, which would then cause the wheels to rotate. The power cylinders and batteries that were 65 kilometers of
Thruster propellant low.
Then slowly make the path. I like to think of this like a circle that slowly shrinks as the day goes on. It would have to stay inside the rover goes down. Walk back to the module with the to make it safe. That means the farthest distance to travel is 25 kilometers. Driving on the moon felt completely different.
Payload released.
It's harder to stop quickly or change direction. Extended scientific missions. They would stay longer, travel farther, and do more experiments than the previous missions. And they would do it in style. They, of course, did have a few problems. For Apollo 15, they landed on a rim of a small crater, making it more difficult to deploy the rover when everything was tilted. Then the front steering didn't work at first. Luckily, they could still use the wheels in the back to steer the rover. Then on the last mission, one of the astronauts' tools snagged on part of the fender and broke it off. And they had to get creative to fix it. Otherwise, it would have sprayed lunar dust all over the vehicle. Overall, the lunar rover was a tremendous success. It allowed them to cover more ground and see some incredible views. There was more time actually doing science. Even today, these rock samples are still being studied at NASA.
T-minus 20 seconds.
On the first
All systems nominal.
walk. Then on the last mission,
12,
how far
11, 10,
total of 30
9,
kilometers.
8, 7, 6, 5. Engine start. 3, 2, 1. Liftoff. Tower cleared. Commence roll program. Approaching engine cutoff. Engine cutoff. Stage SEP. Start SEP.
This is data that the entire world can see, and that's okay. However, you personally have data that you probably don't want to share, like your home address, phone number, or financial data. This is why I'm excited to share today's sponsor, Coffee. This is an online service that lets you remove
Fairing SEP.
information from the internet. This drastically reduces the
Stage SEP. Start SEP.
You've seen the news like this, and
Payload released.
Take back your personal data with Incognito. Use code Jaredon at the link below and get 60% off an annual plan. Before they unfolded the lunar rover, they had to get some things ready. This part of the lab is called the porch. As the commander crawled out backwards, he would reach out to the left side and pull a D handle. This lowers MESA, modular equipment stowage assembly. This contains a few parts that will be installed on the rover. Once both astronauts are on the surface, it's finally time to deploy the rover. On Apollo 15, the first time they used the rover, they set up a camera right here. This is how we got the actual footage of this happening.
T-minus 20 seconds.
20 minutes. Let's walk through this step by step.
All systems nominal.
On the lunar rover, there was a thermal cover. This was rolled back.
12, 11,
Then there were
10,
straps.
9, 8, 7, 6. Engine start. 4, 3, 2, 1. Liftoff. Tower cleared. Commence roll program. Approaching engine cutoff. Stage SEP. Start SEP.
These wheels are spring-loaded. They want to rotate outwards, but they are held in place by the wheel struts. Inside here, there are pins holding the struts in place. found there were two operating tables. Now was time to pull on the left side. This released tension on the center guide cable, which allowed the saddle to finish the job. The cable was then pulled to release the saddle assembly. There's a little bit of
Fairing SEP.
rover was then picked up by hand and moved away from the left. Remember, they can lift it because the moon had a lot less gravity. The tripod is the front the weight limit.
Thruster propellant low. Approaching engine cutoff.
Just did a lunar flyby. Right.
Engine cutoff.
No, exploring.
Last mission, they finally captured the entire liftoff. Time was incredible quality. Lessons learned from the lunar rovers helped to build future programs like the robotic rovers that were sent to Mars. Today, NASA is returning to Earth, building modern lunar terrain vehicles planned to be used early next year. These will be much more advanced and stay on the surface much longer. And it all started more than 50 years ago with 3 lunar rovers just like this one that are quietly still resting on the surface.
Oh, it's Mars, alright. Let's go back to the scene from earlier. Stepping into space without a suit. What would happen? Our bodies are used to the conditions here on Earth. There's air to breathe, pressure on your body from the atmosphere, just the right temperature, and our atmosphere protects us against radiation and micrometeoroids. In space, you've got none of these things. You lose consciousness in seconds and survive in a few minutes. That's why astronauts need spacesuits. Our one-person spacecraft provides oxygen, maintains pressure, keeps the temperature comfortable, and protects against the dangers of space. The challenge is creating suits that are also flexible enough to complex tasks in space. NASA started building spacesuits in the 1960s. Each space program gave them protection and even the ability to walk on the moon. Then came improved spacesuits for the space shuttle. And this spacesuit is still in use today. Commercial space companies are creating their own suits that are sometimes used by NASA. And there will also be 2 new spacesuits coming on the mission. with a MAG, or maximum absorption garment. Yes, basically an adult diaper. When you're sealed up in a suit for up to 8 hours, you have to go somewhere. But don't think about that too much. Then they put on the LCG, or liquid cooling ventilation garment. It has nearly 100 meters of tubing to circulate water against the astronaut's body. The suit will trap heat, so this is the secret to keeping them cool throughout the spacewalk. Now the layers of the actual spacesuit. Each layer has a very specific purpose. First is the pressure bladder. It's a tough fabric sealed with a rubbery coating, almost like a balloon. The restraint layer is like a tough woven fabric you'd find on a backpack. Loads for the bladder. The bladder and restraint are carefully shaped to allow the joints to bend in a specific way. Think of it like one of those bendy straws you can use in the rest of the layers are part of the polymer garment. This is the liner. It's like the material. Next are multiple layers.
Which spaceship are we? The Center 5, the Space Shuttle, or the SOS? Or did we get the pick? Oh no.
Next is the lower torso assembly. This has a hard metal ring at the top called the body seal closure. This is what connects to the heart. Then more ring connections down below. Waist has bearings to allow for some turning, but other than that, not much movement in the lower torso assembly. Putting on a spacesuit is a lot of work. I had the chance to visit NASA and actually put on an EMU. I needed a lot of help to get inside and connect the different pieces. The full spacesuit weighs about 275 pounds here on Earth. This is part of the reason why they wouldn't let me walk around in it. Let me now show you the process of getting into a spacesuit. The astronaut first puts on the MAG and then the LCBG. We saw these earlier in the video. Then they get inside the lower torso, often called the most expensive torso ever repaired. Upper torso is usually mounted to a stand or airlock wall. It's a tight fit and usually takes some practice to get into. Someone nearby will connect the LCBG. This is how the water will flow to cool the astronaut. The astronaut cannot reach the lower torso, so with a little more help, the two halves will be sealed together with the body seal closure. The astronaut will next put on the communications carrier assembly, sometimes called the sleep. It has microphones and speakers so they can talk to other astronauts and mission control. Next,
Guys, can y'all don't tell me what rocket ship is this? And that only real sense rocket. I don't know what they mean by it's the Artemis rocket. Wrong color, buddy. It's orange. Not white. Orange. All I can say is that they were trying to make the sci-fi rocket. They were good at making it. I do not know how to work this out of it.
Understanding things in new ways that I've never seen before. Brilliant helps you level up your skills for wherever the future might take you. To get started for free, go to brilliant.org/JaredOwen.
They need to stop launching these rockets.
On the ISS, when they do a spacewalk, it's called an EVA. It takes several hours to get prepared for it and get completely suited up and ready to go outside. Astronauts
Oh, don't get squished.
They use multiple tethers to stay attached to the station. Unlikely enough to become detached from the station. Simplified A for EVA. watch another space video by clicking here. And thanks again. Building the International Space Station was a huge effort. The early stages of construction involved putting together the pressurized modules where astronauts can live and work. But for this video, let's take a look at building the integrated truss structure. You can think of this like the backbone of the station, holding everything else together. Building the truss took more than 10 space shuttle missions and more than 9 years to complete, with a few problems along the way. Okay, so picture this. It's 2007, and they are moving a large piece of the truss called P6 to its final location. But when they unfolded the solar array, it ripped. It's way out there on the end, and there are no spare parts for this. This led to one of the most daring spacewalks ever attempted. But before we can cover this story, some background. Let's zoom out for a moment. This is what the station looked like when they completed it in 2011. Today it looks mostly the same. You see a few extras like the solar arrays. Well, let's keep things simple for now. The integrated truss structure spans more than 100 meters. That's about as big as a commercial airplane. The truss is the longest structure ever assembled in space. Here's the major parts that are attached to it. The 8 solar array wings to power the station. Radiators to cool the station. Batteries to store power. External storage platforms for storing extra parts. And the robotic systems for moving things around the station. But why a truss at all? It was a design choice, very specific to the space shuttle. But keep in mind, the space shuttle was designed in 2011. Each module on the station wouldn't have built its own power and instead, NASA decided to build these systems on a large array.
Minus X minus 10,
Truss
9,
separated into
8, 7, 6, 5, 4.
Started in 1988, Sorry, launched by a proton rocket. And Unity, which was the first piece brought up by the space shuttle. Then as the service module, launched by a proton rocket. Z1 and PMA-3 were then added by the space shuttle. Z1 is not part of the main truss, but it was essential in the early stages of construction. Once Z1 was installed, astronauts were able to start living aboard the station permanently. They usually spend about 6 months aboard the station before another crew comes up to replace them. Notice how the station sometimes has other visiting spacecraft, bringing new crew members and supplies. Now, at this point, we're ready to start building the main truss structure. In this video, we're going to go through quite a few space shuttle missions to show how this works. And the last one had some of the biggest problems. Let's start at STS-97. This mission brought up the first large piece of the truss. December of 2000 was the STS-97. Remember that STS stands for Space Transportation System. It's how NASA numbered space shuttle flights. This is the Space Shuttle Endeavour. The P6 truss segment is P6 is the port side of the station. Since this was the first piece, it was temporarily without
Minus X minus 10, 9, 8, 7, 6,
the orbiter boom sensor on the ISS. It was designed to extend the
We got Sarge. Sarge. Sarge.
Minus X minus 10, 9, 8, 7, 6, 5, 4, 3.
That helped a little bit, but the ultimate solution was to lift one of the astronauts using the Canadarm, and then use an improvised tool that they called the cheater bar. It was used to free the stuck section, and then finally the array could go all the way. In June 2007, they delivered the S3-S4 truss, then retracted the P6 starboard array. This time the process went much better. In August 2007, the S5 truss. The station is starting to look like the ISS we know today. We still need those outer arrays. One of those outer arrays is P6. It's finally time to relocate. Under normal circumstances, this is already a complex mission. The flight delivered Node 2, or the Harmony rocket. This was temporarily installed to the port side of Unity. Later, it would be relocated after the shuttle left. But the major challenge of this mission was P6. Its radiators and solar arrays had already been retracted on the earlier flights. Astronauts had to manually unbolt it, then slowly move it using the
Yo, watch out.
The two solar panels.
Don't get
Array
squished.
deployed, and there were no issues.
Now, here,
Second one,
guys,
well,
let's
before it was complete,
have
they
a
had to
nice,
stop the
clean
deployment. Astronauts
squish.
noticed a tear between the panels, at first hidden by poor legging. But how did this tear happen? Let's get a close-up look. There is a guide wire that runs along the panels as they unfold. The wire had
egg on this computer. It is hot. It gives his computer a break.
Here's the front of the station. It always travels in this direction. So this is forward and aft, port and starboard, and then there's zenith pointing away from the Earth, and nadir pointing towards the Earth. These terms are part of the regular vocabulary of an astronaut. We'll be using them a little bit throughout this video. This is what the completed station looks like. This part the astronauts are living on the pressurized modules. When I say module, I'm referring to one of these cylindrical pieces of a
game is really planned out. I actually created this game on a different account because this one's brand new. So.
There are two main sections of the station: Russian orbital sector. These are modules from Russia, and the United States orbital sector. These are modules from the United States, Europe, Japan. You can see how the modules on each
I
side
created the game.
on the US side, the modules are connected by the common vertical connector, EM. There are two different sides to this: the active side and the passive side. Once these are brought together, the latch will pull them closer, then there are 16 bolts front and main together. The space between is called the vector. This will be pressurized to prepare the front vector to power. Then the hatch is open, the hardware is removed, the connections are made, and the module, oxygen, power, data, and water. Once finalized, there's a white protective barrier in place. The astronauts can now remove freely individual modules. The common vertical connector is used for modules that are permanently attached together, like the Harmony and Vector modules. They can also be used for specific spacecraft, such as the SpaceX Purple. The Russian side of the station uses a different docking mechanism than the non-compatible SpaceX. In some ways, the mechanism is like a this is kind of like using a power plug in the United States, bringing it closer to Europe. It's not compatible with the wall plug. We need gas turbines. It's the same concept on the space station, but on a larger scale. Two different mechanisms going into the gas turbine. This is called pressurized radiation adapter, or PMA. The larger side is the PEM, which can be attached to the west side of the station. The smaller side is the APAC, compatible with the Russian side of the station and the space shuttle.
6-7 in the chat. 6-7 in the chat.
PMA-1 is permanently placed connected to either side of the station. PMA-2 and PMA-3 docking ports of the space shuttle. The smaller side, which is the side that the space has, is the space shuttle. This is how it docks to the space station. Both PMAs now have yet another adapter in. This allows for more modern spacecraft to dock to the space station. If you'd like to see this in action, watch my SpaceX Crew Dragon video. I'll leave a link in the description below. Now let's take a quick look at the space shuttle. The crew spent most of their time up here in the
Wow.
back here in
Wow.
the slow bay.
It's so
Where the
good.
space station modules were carried out into space. Up front here is the orbital docking. This is the place to dock with the international station. The astronauts can also do spacewalks at night. On the side here is the camera. The robotic arm is capable of moving around in space. The arm can be controlled from the inside of the space shuttle and into orbit station. The space shuttle launches this place to the Kennedy Space Center in Florida. Once in space, the payload-based doors are open. They remained open for the entire time they were in space. Then it took a few days for the space shuttle to catch up with the ISS. The space shuttle is retired now. Displays show logos and buildings being visited. Let's take a look at the previous space shuttle mission. This first mission will go over the once you're ready to get to the timeline, how long it took. And then for the next mission, we'll go over a little bit further transmission level. The first mission we'll talk about is STS-82. December of 1968. The STS stands for the Space
Alright.
Communications System. All shuttle missions start with these three letters.
So,
This was the first shuttle mission to
you
the
want
International Space Station.
what you
This
need
time, the station had only one mission.
inside
Russian
Roblox.
rockets orbiting the Earth all by
Yes.
itself. On the
I already have
this
subscribed
is where it's already
and
This first shuttle mission was brought up. This is kind of like the central hub. Next version for other modules attached.
Let's go. Next subscriber, next
On day
subscriber.
3 of the mission, Cannonball was restored. Time to take out of the payload program. DMA-2 was then attached to the orbital docking shuttle. The Canadarm, large mass of space with a great long orbit, had to move very slowly, not spraying the robotic joints, and took hours to complete. Very
And subscriber 0.
the shuttle's thrusters were fired during the launch.
Have a lovely day.
The Canadarm turned on again, the shuttle's thrusters were fired during the launch. It took a few more days of preparation before they could go inside the station. There were 2 EVAs that go outside the station.
Have a lovely
They
day.
connected cables and installed antennas on the outside
Have
of
a
the station.
lovely day.
The Canadarm was used to help move the astronauts
Have a
around.
lovely day.
On the 8th day of the mission, they opened the hatch and entered the station for the first time. They only stayed inside for about a day. It's enough to check things out and prepare us for the next mission. On the 10th day of the mission, there was one more EVA to finish the installation. Then on the 11th day of the mission, the shuttle undocked and
Jose. Have a lovely day. Special message. Can you guys please do this? Subscribe, please. Did not mean to draw that. Sorry, guys. It's just 8. I'm not sure if I can read that. Got so many walls. Blank ones. I can't even see other people's. This is my store, guys. So nice. know if y'all like this movie. Just tell me. I'm barely home. Alright guys, y'all better subscribe.